Hey guys, welcome back to my YouTube channel Med Edophilia. From today, we are going to start with chemistry and that too from the very basic. So, we'll be starting with the first chapter of class 11, that is some basic concepts of chemistry. We all know chemistry is just not a subject, it has multiple branches in it: organic, inorganic, physical, analytical, biochemistry, and nuclear chemistry. So, chemistry is nothing but the study of composition, structure, interaction, and properties of matter. Okay, CSIP. C for chemistry and SIP. SIP. Okay, composition, structure, interaction, and properties of matter. So, what is matter here? We all know matter is anything, any substance that has mass and occupies space or volume, and the constituents of matter is atoms and molecules. Hence, chemistry is termed as the science of atoms and molecules. So, chemistry has got n number of applications, especially in medicines, as it is used in the preparation of drugs. For example, cisplatin and Taxol is used in the cancer treatment. Okay, and AZT, shortly we call, okay, azidothymidine. Azidothymidine, not azidothymine. Okay, learn know the difference. And this drug is used for curing AIDS. So, talking about the states of matter, we know that they are solid, liquid, and gas. And these states of matter are interconvertible by changing the temperature and pressure. A solid can be converted into liquid by increasing temperature and decreasing pressure. Similarly, liquid can be converted into gas by increasing temperature and decreasing pressure. Temperature and pressure are always inversely proportional. So, more about these states of matter we will be learning in the chapter states of matter itself. There's one separate chapter, so we'll be learning that. So, we know that the constituent particles in the solid are very tightly packed without any space between them, whereas in a liquid they are loosely packed, and in gas they are very loosely packed and they are very free to move. So, when you heat, okay, when you increase the temperature of a solid, the particles will get separated. The constituent particles, the atoms will get separated from each other. So, the distance of separation will increase. So, they will move far apart from each other, and hence they will convert into liquid. So, do you understand how by increasing temperature and by decreasing the pressure we are actually compressing the solid? Okay, sorry, by decreasing pressure we mean that we are letting it loose. By only when we increase pressure it means compression, I'm sorry. So when we increase pressure for a liquid it will convert into solid because the particles are going to come close to each other. Okay, this process of converting solid to liquid known as melting or fusion, and the reverse process known as solidification or freezing. And the process of conversion of liquid into gas is known as vaporization, commonly evaporation we call it, and the reverse process, that is gas into liquid, is known as condensation. Now, solid can be directly converted into gas without undergoing the intermediate liquid state, and this process is known as sublimation. So now let's move on to classify matter. Matter can be classified into two types broadly, that is one pure substances, second one is mixtures. Pure substances again is of two types, that is elements and compounds, and mixtures again can be classified into two types, homogeneous mixture and heterogeneous mixtures. So pure substance is nothing but anything that has constant and definite composition, whereas mixtures have different varying composition, and it is a combination of two or more pure substances. So pure substances have fixed set of properties, and the properties of mixtures varies because the composition varies. Pure substances can be separated by only chemical means. Mixtures can be easily separated by physical means. We know hand picking, and there are many other physical methods, distillation. So, all these physical methods can be used in the separation of mixtures. In pure substances, only one substance is present. This is particularly for elements. So, let's again look at the differences between mixtures and pure substances. We differentiated mixtures and pure substances based on three headings. One is composition, next is properties, next is separation method. Talking about composition, it varies in mixtures, constant in pure substances. Talking about properties, it varies in mixtures, constant in pure substances. And talking about separation method, physical methods can be used in separating mixtures, and only chemical methods can be used in separating the constituents of pure substances. Okay. Now pure substances again is of two types, as we saw, that is elements and compounds. Elements cannot be broken down into simpler substances by any separation method because it is made up of only a single type of substance. Okay, sodium is an element, chlorine is an element. You cannot separate sodium into any other parts because sodium is just the only constituent present. So an element cannot be broken down into simpler substances, whereas a compound can be broken down into its constituent elements by means of chemical methods. All right, there are 118 elements present, and we know compounds, there are n number of compounds that can be formed. So how do we define an element? An element is the building block of all matter. This is the basic definition. And a compound has definite and constant elemental composition. This is the basic definition of a pure substance. When we take NaCl, that is common salt, okay, we can break it down into sodium and chlorine, that is the constituent elements. How? By means of chemical methods only. Okay. Now let's look at the classification of mixture, that is homogeneous and heterogeneous. The word homo means same. So the properties are same throughout and it appears like a single component. It appears like a single phase. Okay, whereas hetero means different, so the properties are different and they vary throughout, so it appears like different phases. Okay, when we take salt solution for example, it just appears as one single entity. We do not see salt separately and water separately, right? So salt solution is an example of homogeneous substance, homogeneous mixture. And whereas heterogeneous, when you take sand and water, sand gets settled down after some time and the suspension, that is the water, floats in the along with the lighter particles. So you can observe two different phases here. So this is an example, typical example for a heterogeneous mixture. So homogeneous mixtures are true solutions, and heterogeneous mixtures are nothing but colloids and suspensions. This again you will learn in about true solutions, you will learn in the chapter solutions, okay, of class 12, and suspensions and colloid you will learn about these in the chapter surface chemistry, that is again in class 12. So the components of mixture can be separated using physical methods. So what are those physical methods? Hand picking, filtration, crystallization and distillation. These were the physical methods that I was talking about. The next part of the chapter is about measurement, okay, units and conversions, same as that we saw in physics. So I will only be discussing those points which are different, which are something new which you have to learn given in the chemistry textbook. Okay, first conversion you need to know is the conversion of liter into meters. You all know 1 liter is 1000 centimeter cube and 1 centimeter cube is 1 ml. So 1000 centimeter cube is 1000 ml, which is equal to 1 decimeter cube, and 1 decimeter cube is nothing but 10 power minus 3 meter cube. So remember, 1 meter cube is equal to 1000 liters. So how will you remember this? So imagine a big box or a big tank which is present in the roof of your building. Okay, and the dimensions is 1 1 1. That is, it has length, breadth, and height equal to 1 meter each. So in that container, you can store up to 1000 liters of water. So 1 meter cube, that is in 1 meter cube volume, you can store up to 1000 liters. This is how you can remember. Okay. So next talking about temperature scales, that is different temperature scales, Celsius scale, Fahrenheit scale. We know that the Celsius scale is calibrated from 0 to 100 degrees. That is, the lower fixed point is 0 and the upper fixed point, that is the boiling point of water, is 100 degrees Celsius. Whereas in Fahrenheit scale, it is between 32 and 212 degree Fahrenheit. So this formula, that is of converting the temperatures into different temperature scales, is essential. So for this you just need to remember two basic formulas. One, C by 5 is equal to F minus 32 by 9, and the second one is K is equal to C plus 273. Okay, so when you remember this, all the conversions related to the different temperature scales will become easy. Okay, now here we have to note an important point. We should note that negative temperatures, okay, are possible only in Celsius scale but not in Kelvin scale, because the lowest value itself in Kelvin scale is 0 Kelvin. The minimum possible temperature in Kelvin scale itself is 0 Kelvin. Okay, that is the absolute zero, where the motion of all particles of matter stops and there is no interaction at all. So there is no negative temperatures in the Kelvin scale, whereas it is possible in Celsius scale. So the next topic is about unit, that is the reference standard. We have already learned this in units and dimensions in physics, but I have put here the important points in your NCERT textbook that you tend to overread or just ignore, because thinking that you already know all these. Okay, here are some factual points that you need to remember, so that when these questions come appear in your exam paper as options, you need to know the actual fact. So without knowing this fact, you will not be able to answer. Okay, so we know that kilogram is the SI unit of mass. This kilogram was defined using platinum iridium. Okay, why? Because platinum iridium was chosen as the standard because it is highly resistant to chemical attack. Okay, because of its high resistance, and so its mass does not change for an extremely long time. So for two reasons: one, it is highly resistant to chemicals, and second, its mass does not change for a long time. So platinum iridium, okay, cylinder was used to define kilogram as the reference standard, that is the unit for mass. So this is one factual point that you should learn, and it's given in your NCERT. Do not skip it. Okay. Second one was given about significant figures. We have already learned the rules, how to add, subtract, multiply, divide, everything, how to perform arithmetic operations. Okay, different rules, rounding off, order of magnitude, everything we have learned in physics. So here I will only tell one point which you need to remember and which is given in your book and which is not there in your physics textbook. Okay, so what they've given is infinite significant figures are there for exact numbers, that is for pure exact numbers. For example, when you say 2 balls, 20 eggs, 20 pens, 40 books, like that, so these are all pure numbers. Okay, these pure exact numbers, they have infinite number of significant figures. Why is that? For example, when you say 20 books, okay, you can write 20 as 20.0000. You can write infinite number of infinite number of zeros after the decimal point. So that is why we say pure numbers or exact numbers have infinite significant figures. So this is an important point to remember. Now let's move on to the actual chemistry part. So till now it was just brief introduction, okay, of what we've already learned. So now let's move on to the actual chemistry part. So there are basic laws of chemical composition. So firstly we have law of conservation of mass. I think you would be very familiar with this. When considering a simple equation, that is formation of water, H2 plus O2 is equal to H2O. Okay, when we take 2 grams of hydrogen and 16 grams of water, we will find that only 18 grams of water is being formed. So 2 grams of hydrogen and 16 grams of oxygen, we find that only 18 grams of water being formed. So what does that mean? The sum of the mass of the reactants is equal to the mass of products. So there is no loss in mass at all. So whatever the mass is being consumed in the reaction, that is in the reactants, same amount of mass of products will be obtained. All right. Next we move on to law of definite proportion. Law of definite proportion or law of constant composition states that a chemical compound always consists of the same elements combined together in the same definite proportion by weight, by mass, okay, irrespective of the method of proportion preparation or the source from which it was taken. Okay, I repeat, any compound we know that it consists of the same elements which is combined in the same definite proportion by mass, and this is does not depend on the method of preparation or the source from which it was taken. Okay, so let's take water from a lake water. The lake water's formula is also H2O, isn't it? And drinking canned water, you see, that's also H2O. So the ratio of hydrogen and oxygen is 2 is to 1. Okay, sorry, I wrote this wrong. It is 2 is to 1, H2O. So this ratio is always same irrespective whether the water was taken from lake or it was from the drinking water. Okay, so this is what the law of constant composition means. So let me give you another example. Carbon dioxide can be prepared from various methods. Okay, first one by simple combination of carbon and oxygen. Second one by the decomposition of calcium carbonate or limestone. Third one is by the combustion of hydrocarbons, methane or alkanes. We again get H2O and CO2. So whenever hydrocarbons, that is alkanes, are burnt, that is combustion, the same products will be obtained. It is always H2O and water because this is complete combustion which is taking place. So remember this. So you find that in all cases CO2 is being formed. So different methods of preparation. Can you see? So in all these reactions, all these different methods of preparation, the composition, the ratio of carbon is to oxygen is only 1 is to 2. This ratio is always constant irrespective of the method of preparation. So I hope now you've got the actual meaning of the law. Next we move on to law of multiple proportion. When two elements combine to form two or more compounds, okay, then we say that the masses of one element which combine with the fixed mass of the other element, they are present in the simple whole number ratio. So two elements, they are combining in simple whole number ratio to form two or more compounds. Whereas we let's consider an example. We say we take two elements, hydrogen and oxygen. These two elements, they are combining in simple whole number ratio to form different compounds, H2O, H2O2. First one ratio is 2 is to 1. Second one 1 is to 1. 2 is to 2, that is 1 is to 1. Next, again, to understand, I'll take one more example, carbon and oxygen. So we are considering two elements. These two elements has to be same for all the different compounds that we are going to form. So what are the compounds that can be formed from C and O? CO and CO2. So what is the ratio in which these two elements are combining? 1 is to 1 and 1 is to 2. So aren't these simple whole number ratio? Yes, these are simple whole number ratio. So these CO and CO2 exhibit law of multiple proportions. Next again I will take one more example. Two same elements. Let's consider nitrogen and oxygen. And let's see what are the different compounds it's going to form. NO, NO2, N2O, N2O5, N2O3. So in all these, what is the ratio? 1 is to 1, 1 is to 2, 2 is to 1, 2 is to 5 and 2 is to 3. So these are all simple whole number ratio. So I hope now you are understanding law of multiple proportions. Next we move on to Gay-Lussac's law. Okay. For this, Gay-Lussac's law talks about volume. All right. So Gay-Lussac's law of combining volume. It states that when gases combine or produced in a chemical reaction, they do so in a simple ratio by volume, provided all gases are at same temperature and pressure. So there is uniform temperature and pressure maintained. So Gay-Lussac's law is about the volume. So let's consider a simple reaction. H2 plus Cl2 gives rise to 2HCl, all in gaseous state. So when one volume of H2 combines with one volume of Cl2, two volumes of HCl is produced, as we can say from the stoichiometric coefficients. So all these reactants and products, they are present in simple ratio, that is 1:1:2. So this is what is stated in the Gay-Lussac's law of combining volume. Let's take another example. It is the formation of ammonia. N2 in gaseous state plus 3H2 in gaseous state gives rise to 2NH3 in gaseous state. So the ratio is 1:3:2, again the simple whole number ratio. So Gay-Lussac's law can be observed in this equation. So at a given temperature and pressure, the volumes of gases which react are the ratios of small whole numbers. Alright. So next we move on to the next law, which is the Avogadro's law. Avogadro's law is simple. It just means equal volumes of gases contain equal number of molecules at standard temperature and pressure. Alright, so the volume of the gas is simply directly proportional to the number of molecules. Equal volume of gases contain equal number of molecules at standard temperature and pressure, that is STP. Same equation we consider. H2 plus O2 gives us to H2O, all in gaseous state. When 2n molecules of H2 is used, n molecules of O2 is used, and 2n molecules of H2 is used, we find that 2n volume and 1 of H2 and 1 volume of O2 and 2n volume of H2 is produced. So what do we observe? That there is direct variation of volume of the gas and the number of molecules. Next we move on to Dalton's theory. So all these basic laws of chemical combination led to Dalton's theory. So before discussing about this theory, I would like to ask you one question. What is an atom? Does an atom have independent existence always? Okay, so the smallest particle of an element which may or may not have independent existence is called an atom. Okay, so for example, when you take hydrogen, it exists as H2 molecule in the atmosphere and not as H atom. That's why we say it may or may not have independent existence. But the smallest particle of a substance which is capable of independent existence is called a molecule. So a molecule is always able to exist independently, but an atom may or may not exist independently. This is one point I wanted you to keep in mind. Okay, now let's move on to Dalton's atomic theory. So there are mainly 5 postulates. First one says all substances are made of tiny indivisible particles called atoms. Yes, it's quite obvious. Second one, atoms of the same element are identical in shape, size, mass and other properties. So the same element has similar atoms. That's what they are trying to say. Third point, atoms the smallest atom of different elements have different in all aspects. Just the reverse of the second point. Fourth point, atom is the smallest unit that takes place in chemical combinations. So the smallest entity taking part in a chemical reaction is an atom. Okay. And the fifth point is that an atom is indivisible. That is, it cannot be divided further. It cannot be divided, destroyed or created. That's what the fifth point is all about. So till now we have seen various laws of chemical combination. Let's have a quick recap of that. I'll be adding new points to this. First one, we saw conservation of mass. This conservation of mass law was given by Antony Lavoisier. Okay. And what is the exception of law? When you ask me, this law is not universal. That is, it's not applicable to all the cases. Exception to this law is the radioactivity or nuclear reaction. Okay, Einstein gave this equation, the very famous equation, that is E is equal to mc square. From this we come to know that some amount of mass is converted into energy. So nuclear reactions and radioactivity are exceptions to conservation law of conservation of mass. Second law we saw, it was law of definite proportion or constant composition. So this law was put forward by Joseph Proust. Okay, and the exception to this is isotopes. For example, you say hydrogen, deuterium, and tritium. Okay, these are all isotopes. So isotopes are an exception to the second law we saw, that is law of definite proportion or constant composition. The next law we saw was law of multiple proportion, isn't it? Or law of independent proportions, also known as law of independent proportion. This law was again put by John Dalton. Okay, same person who put forward the Dalton's atomic theory. An exception to this law are the compounds formed by transition elements. For example, non-stoichiometric compounds, that is Fe 0.980, for example, you see that these are not combining in simple whole number ratio, which means it is an exception, or it is different from what stated in law of multiple proportions. Similarly, if Fe 0.960 is also possible, so multiple compounds like that are possible. Second exception is about interstitial compounds. Similarly, these are also not stoichiometric. Okay, for example, TiH 2.7, for example. You see in the crystal lattice of titanium, very small atoms like hydrogen, carbon, boron get occupied. So such compounds are known as interstitial compounds. So TiH 2.7 is a perfect example. This again is an exception of law of multiple proportions. Next, we move on to Gay-Lussac's law, or law of combining volumes, or law of constant composition of gases. The very name, we can come to know that this law was put forward by Gay-Lussac. Okay, and the exception or the limitation to this is that all the reactants and products must be in gaseous state only. So we always talked only about gases and not about solids or liquids. So that you should just keep in mind, it is a limitation. Okay, next we move on to Dalton's law. What is the name suggests that it is put forward by Dalton, of course. And what is that limitation or exception of Dalton's law? So, first, the fifth point that we discussed, that a postulate that we discussed in the Dalton's atomic theory, that atoms cannot be uh, created, divided, or destroyed during any chemical or physical change. That's what we discussed. But we all know that atoms are divisible. They can be divided into further smaller particles like proton, electron, and neutron. And these again, proton, electron, neutron, can also be further divided, which we're not concerned as of now. Okay, so atoms are not the smallest constituent of matter. So because atoms again can be divided further into smaller particles. So this becomes a limitation of Dalton's atomic theory. So let me give you a question based on these basic laws of chemical combination, and let's see if you are able to answer. Question is, C2H8 and C2H6. These compounds obey which law? That is the question. Is it law of constant proportion, law of multiple proportion, or Gay-Lussac's law, or law of reciprocal proportion? What is it? So firstly, we have to write the ratio of carbon to hydrogen. First compound C2H8, the ratio is 1:4, 2:8, which is 1:4. And for C2H6, the ratio is 2:6, nothing but 1:3. So we find that same carbon and hydrogen are forming two different compounds as given in the question, and the ratio is also in simple whole number compounds, so, whole number ratio. So what is it? When same elements combine and form different compounds in simple whole number ratio, yes, it is multiple proportion. So these two compounds obey law of multiple proportion. Again I gave you a question, C2H8 and CH4 obeys which law? So again you're seeing two compounds, two elements, that is carbon and hydrogen. They have formed two different compounds, isn't it? That's what strikes you when you see this question immediately. So immediately you will tick the answer as law of multiple proportion, which is wrong. Always what you should do is write the ratio of carbon to hydrogen. 2 is to 8 is nothing but 1 is to 4 in C2H8. And in methane, CH4, the ratio is again 1 is to 4. So the same ratio, which means that it is the same compound. So when two elements, they are forming the same compound irrespective of the source, irrespective of the method of preparation, it is nothing but law of constant composition. Okay, the answer is law of constant composition and not law of multiple proportion. So be careful in such questions. So I hope you are now clear with the basic laws, and please practice questions on these laws and do not neglect that these laws are very simple and questions will not be tested. So I recommend you to practice questions on each and every topic irrespective of how less important you might feel in your mind. Okay. Next we move on to the topic of AMU, that is atomic mass unit. Atomic mass unit, that is 1 AMU, is defined as a mass exactly equal to 1/12 the mass of one carbon 12 atom. So carbon 12 is nothing but a stable isotope of carbon. So this carbon 12 isotope has an exact value of 12 U or unified mass. So it is actually a relative comparison. Atomic mass or AMU is nothing but the mass of the atom by 1/12 the mass of carbon 12 atom. So U is the unit which is used most commonly nowadays than AMU. So you should remember that 1 AMU is equal to 1.66 into 10 power minus 24 grams, or in kgs if you have to convert, it is minus 27 kgs. So this is an important conversion between AMU and kg that you need to keep in your mind. So before diving into the concept of average atomic mass, let me give you a few questions on finding the gram atomic mass, that is the AMU value of the molecular mass values of different compounds. The first question is to find the molecular mass of CO2. We know for carbon it is 12U, and for oxygen the mass is 16U. For most elements it is double the value, okay, double the atomic number, not for all. For some it is double the value plus 1. So using this you can simply remember, for most of the commonly used elements it is double the value, the mass is double the value of the atomic number. Okay, so for CO2 it is 12 plus 2 times 16, 12 plus 32, which gives us 44U. So gram molecular mass is nothing but molecular mass expressed in grams. So when in the question when they ask what is the gram molecular mass of carbon dioxide, it is simply 44 grams. Similarly, when they ask you gram atomic mass, it is nothing but atomic mass expressed in grams. So you don't have to convert grams into U and all. Okay, that is by multiplying that U into 1.66 into 10 power minus 24. You don't have to do that. What is the meaning of gram molecular mass? We are simply expressing the mass in unified, that is U or AMU, into grams. That is simple. Make it simple. The value remains same. Instead of U, you just have to write grams. That's it. Grams or kg, whatever they asked. Next question. Find the molecular mass of sugar. So now you might be wondering what is the formula of sugar. So for such questions, you first need to know the chemical formula of the compound given. Sugar is nothing but sucrose, which has the formula C12H22O11. C12H22O11. So 12 times 12 carbons atomic mass plus 22 times 1 plus 11 times 16. So 12, 1, 16 are the atomic masses of carbon, hydrogen and oxygen respectively. So 144 plus 22 plus 176 gives us 342 grams as the gram molecular mass of sugar. So remember, this will be tested in many questions. It's actually a repeated one. So just remember, molecular mass of sugar is 342, or else you have to sit and calculate this whole thing. Okay. Second one, find the molecular mass of glucose. So what is the formula of glucose? C6H12O6. So you can calculate, you will get the answer as 180 grams. So this is also a repeated compound for which you need to know the molecular mass by heart. It's easy. Okay, once it's repeated many times, it will automatically get stored in your memory. So it is 180 grams. So sucrose is 342 grams, glucose is 180 grams. Remember. And now I'm going to talk about the difference. Okay, there are two terms which are commonly confused and misused, okay, interchangeably. One is molecular mass, second is formula mass. Actually speaking, both are the same, but they are used for different compounds. Molecular mass is used for covalent compounds, and formula mass is a term used for ionic compounds. So covalent molecules like CH4, H2O, SO2, CO2, C12H22O11. What is this? It's the formula of sugar or sucrose. And glucose, C6H12O6. And what is formula mass used for? Is used for ionic compounds. Example, NaCl, BaSO4, KCl, MgCl2. All these ionic compounds which can be split into their constituent ions. Okay, so when NaCl is dissociated, it dissociates into charged species of Na plus and Cl minus. And that's why this compound NaCl, we say it is an ionic compound. Okay, these ionic compounds do not contain discrete molecules because they have ions, positive and negative entities, ions as their discrete units. These positive and negative entities are arranged in a three-dimensional structures. That is why we use a new term, formula mass, and not a molecular mass. Okay. So I have written a point over here which is important, and this point you will learn in solid state, that is in NaCl, common salt, rock salt. Okay. One sodium Na plus ion is surrounded by 6 Cl minus ion and vice versa. That is, the coordination number is 6. So I will teach you more about this, okay, in solid state of class 12. So next we move on to the concept of average atomic mass. So why this becomes important is, most of the elements present in the environment, present in the atmosphere, does not exist as a single substance. Okay, it does not exist in a single form, and many of them have different isotopes present in nature. So finding their relative abundance, okay, and they have different relative abundances present in nature, present in our surroundings. So when we say chlorine, there are many isotopes of chlorine. So when you ask me what is the mass of chlorine, we say the average value of all the isotopes of chlorine according to their relative abundances, and we reproduce as a single value, and that single value we take as the mass, average atomic mass of chlorine. So this becomes extremely important. So the relative abundance, the percentage abundance, is the relative abundance present in the nature. It is that abundance of the isotope which is present, that exists in nature. So let me give you a question which says, chlorine that is 35 Cl and 37 Cl, is present in nature with relative abundances 75.76% and 24.24%, and the atomic mass of 35 Cl is given as 34.97 AMU, and that of 37 Cl is given as 36.97 AMU. Now we have to find the average atomic mass of chlorine. The first step is to convert the percentage into fractional abundance. Okay, so for that you need to divide by 100, isn't it? Percentage 75.76 percentage means 75.76 by 100. So you should simply multiply the atomic mass of individual isotopes into their relative abundances to get the average atomic mass. So the answer is 34.97 into 0.7576. That is what you get when you divide by 100, plus 24.24 into 0.3697. So multiply, open the bracket, multiply and add, and tell me what you get. We get 35.45 AMU. So you should be fast in your calculation. That matters here, and that is important here. Okay. So if you are a lazy person, okay, and if you find, okay, who will sit and multiply like this, and okay, and you want a shortcut to find the average atomic mass right from the options itself, what should you do? I am here to give you a trick. So the average atomic mass, that is the final answer, is always close to the mass of the isotope which is having a higher relative abundance in nature. So this is your key statement, the key trick which will help you solve such questions without even multiplying. Just by seeing the options, you can easily guess. So look at this question. The higher percentage, that is 75.76, this is much higher than 24.24 percentage. So 35 chlorine is present in a higher relative abundance than the other isotope. So the average atomic mass, will be closer to the mass of the isotope having higher relative abundance in nature. So the mass will be closer to 34.97. So 34.97 is approximately 35. So when you take a mid value, you will get 35.45. Okay, so you have to just round off. 34.97 is simply, you can take it as 35 approximately, and 36.97 approximately you can take it as 37. So the answer should be closer to 35, but a little more than 35, because there is a 97 over here, isn't it? So the answer will be 35.45. You won't get 35.95, because otherwise it will become closer to the value 36.97. So you will get the answer. You should always take the mid value 35.45. I hope you are able to understand. Okay, so by using this simple trick, you will be able to find the answer just by looking at the option. So I will solve another question, and you try to solve this question using the trick which I told you now. So here is the question I have displayed. You should find the average atomic mass of carbon. They have given you the different isotopes. They have given the masses, individual masses of the isotopes, and their percentage abundances. So pause the video and try it out. Okay, I hope you've got the answer. So first step is to observe the question carefully. So from the question you find that one of the percentage is extremely higher than the other one, 98.93 present abundantly, isn't it? And where is that 1%, 1.07%? So you can clearly say that carbon 12 is that stable isotope of carbon which is existing freely, independently in nature. Okay, so the average value will be closest to 12. So what I will say, I will look at an option which has an answer 12. Okay, nearing to 12, just 12, because the percentage is very high. not even 12.27 or 12.37, because 98 and 1, look at the contrast, 98.93, so rounding it off 99, so 99% and just 1%, so the answer will be more 12. Okay, even when you round off the options, you should get the answer as 12. So look at that option. So I will actually calculate the average atomic mass, and let's see how much we are actually getting. So what do we do? 12 into, that is mass, into relative abundance, 98.93 by 100, plus 13 into 1.07 by 100. So solving, I am getting 12.01 AMU. So what is it? It's nothing but 12. Okay. So didn't we guess even before actually multiplying and dividing by 100 and then long addition? We didn't do all that. We guessed it right just by seeing the question. So I hope you will follow this method and make your save your time and use it for other question solving. So this method, that is guessing from option just by observing the question, is very useful unless the given percentages are very close to each other, that is 24%, 25.97%, 26.01%. So if the percentages are very close to each other, then this trick may not be that much useful, because when they are very close, you actually have to do the calculation to find the accurate value, because even the options might be very close to each other. So just don't guess blindly. Okay, so you should know when to use this trick also. Okay. Okay, so we've completed almost the basic concepts now. Now we are moving on to the most important and the topic which plays a vital role to understand other concepts in chemistry, that is in class 12 and as well as the other chapters of class 11 also. That key concept of this chapter is mole concept. Okay, it's very important. So firstly, I'm starting to define one mole. 1 mole is nothing but the amount of substance which has the same three things you need to remember. Okay, what are these same things? The amount of substance which has the same mass as a gram molecular mass or gram atomic mass, the amount of substance which has same volume equal to 22.4 liters for a gases at STP, the amount of substance which has the same number of particles equal to the Avogadro number, that is 6.02 into 10 power 23 particles. So all this is 1 mole of a substance. So 1 mole is any substance which has the amount equal to the mass equal to its gram atomic or gram molecular mass, and volume equal to 22.4 liters, and number of particles equal to Avogadro's number. Molar mass, molar volume, and Avogadro's constant. And STP here is 1 atm and 273 Kelvin, that is STP. So this three statements you can define 1 mole, and these three statements will play an important role in finding the number of moles when mass of a substance or volume of a substance or this many number or ions of substance is given in the question. So using these simple three statements, you can find the number of moles. So what is N equal to? That is, number of moles is equal to the given mass divided by molar mass, the given number of particles divided by Avogadro number of particles, the given value divided by 22.4 liters or 22,224,100, that is 22,400 ml. Okay, so these are the three things you need to remember, which is used in all the questions which we'll be solving further. So now let's solve few questions on mole concept. The first question is to find the number of atoms present in subdivision A, 52 mole of argon. Okay, we all know that 1 mole has Avogadro number of atoms. So how much does 52 moles of argon has? Simply 52 into Avogadro number. So what do we get as the answer? 3.13 into 10 power 25 atoms. Second subdivision is 52 grams of helium. Okay, so first question we had 52 moles, but here it's given in terms of grams. So first step is to convert it into number of moles. Number of moles is given weight 52 by the atomic weight of helium, that is 4, which gives us 13. So number of atoms in 13 moles is 13 into 6.022 into 10 power 23, which gives us 7.83 into 10 power 24 atoms. So what are we doing? First step is to find the number of moles, and then we all know 1 mole has Avogadro number of atoms. So simply we need to cross multiply. So I will give you a different type of question, different model. In 3 moles of ethane, find the number of moles of carbon, number of hydrogen atoms, and the number of molecules of ethane. Okay. So in the question they have given us 3 moles. So what is ethane formula? C2H6 alkane. Ethane is an alkane which has the general formula CnH2n plus 2. Okay. So we know 1 mole of ethane, it has 2 moles of carbon because there is C2 in the formula, isn't it? So in the question is given 3 moles of ethane. So how many moles of carbon is present? Simply cross multiply. There is 6 moles of carbon. So that becomes the answer for our first subdivision. Second, we need to find the number of hydrogen atoms. Okay, so in 1 mole of ethane, we know that there are 6 atoms of hydrogen. How 6? Because it is C2H6. Okay, so we need to find the number of hydrogen atoms present in 3 moles of ethane. So we'll get 18 atoms of hydrogen. So most of the questions here is based on cross multiplication. So it is very simple. Okay, the next subdivision asks us to find the number of molecules of ethane in 3 moles of ethane. Okay, we know 1 mole has Avogadro number of molecules. So 3 moles of ethane will have 3 into 6.022 into 10 power 23, which gives us 1.8066 into 10 power 24 molecules. So let me give another question. Which of the following contains the same number of atoms? Option A, 1 gram of oxygen. Option B, 1 gram of O2. That was monoatomic oxygen atom. This is diatomic oxygen. Option C, 1 gram of ozone. It is O3. And option D, all have the same number of atoms. So we clearly know that this question is from mole concept. So first step is finding the number of moles. So given mass, take option A. Given mass is 1 gram by what is the atomic mass of oxygen? 16. So 1 by 16. So to find the number of atoms, that is what we need to find. We need to find the number of atoms in each of the options and then compare which of the following contains the highest or lowest number of atoms. I'm sorry, the question has to be which of the following contains the highest number of atoms. Okay, I'm sorry. So the number of atoms we calculate by we know 1 mole into its atomicity, that is number of moles into atomicity will give you the number of atoms present. Into Avogadro number you should do, but all the terms will have into an Avogadro number. So for our convenience, okay, instead of simply multiplying everything into Na, we just multiply the number of moles into the atomicity, because that multiplying it with Avogadro number with all the options is not going to affect the overall to decide which one has the greatest number of atoms. Okay, so you get roughly 1 by 16. Take option B. So 1 gram is the given mass by molecular mass of oxygen. So what is the molecular mass of dioxygen? It is 32, because for oxygen atom it is 16, for dioxygen it is 32 into the atomicity. So into 2 again gives us 1 by 16 because it's O2. Take your option C. 1 by ozone has molecular mass of 48. 3 into 16, okay, into 3. 3 is its atomicity. Again it gives us 1 by 16. So we end up that all the options given contain the same number of atoms. So the correct answer is option D. Okay, so for today we'll stop with this because already we've learned a lot, and in my next class I will be giving you few more problems on mole concept and then moving on to mass percentages, empirical formula, molecular formula and stoichiometric calculations. Alright. So if you feel this video helped in getting your concepts clearer, please hit the subscribe button because it will motivate me to make better content and give you more questions for practice. Stay tuned for upcoming videos. Thank you so much.